All right. Hey, let me stick my earbuds in. Oh my gosh. Okay, hold on. I apologize. Okay. Yeah, I didn't. We got a good number today. I was hoping for more, but kind of figured there'd be a few people out for the day. Spring break and all. Um, Hope they get their homework done. All right, so we stopped here. Um, Two vectors are given by A. We found the dot product, and then it asked us to find the angle between A and B. So there's two equations that we had, right? There was this one, A, switch my ink. A dot B is equal to AX plus BX, or times BX, sorry, times BX plus AY times BY. We had another equation, which was the magnitude of A times the magnitude of E times cosine of theta. Right, so we can get that easily. We can get that easily. We already found this. That's -7, right? This is -7.0. So we can use this information to find that theta. All right. So for part two, or for part B of this problem, um, we have A dot B is equal to AB cosine theta. We can solve this for theta. Excuse me. We can solve this for theta. So we're going to get divide both sides by AB. So we're going to get a cosine theta is equal to A dot B divided by AB. Okay, so just remember the top ones are the vector dot product, which we found in part A. And AB is we have to get the magnitude of A times the magnitude of B. Right, so let's finish solving this for theta. We'd get the inverse cosine of both sides, and we'll end up with theta is equal to the inverse of cosine of A dot B divided by magnitude A times the magnitude of B. So I still need the magnitude of A and B, which is easily done here, right? I'm going to do that on the side over here. A is going to equal to the square root of 4 squared plus a -3 squared. That's going to give me 5. And then B is going to equal to the square root of a -1 squared plus a1 squared. That's going to give me the square root of 2. So I can just plug that in as it is. And we already found a dot b. That's -7 again. So theta is going to equal to the inverse cosine of a dot b, which was -7, over a times b. So it's going to be 5 times the square root of 2. You can write it just like that. Okay. So that gives us, plugging that into your calculator, that should give you 172 degrees. Okay. So if I were to draw these out, and I'm not going to be able to do this perfectly, but let's try. Let's see. BA was 4 and -3. Okay, 4 and -3. So let's say that's about 4 here, and -3 is about here. So that's my A. And then if I were to draw B, B is -1 and 1. So that's about right here. Let's draw it in green. It's about, let's see, that's 1, that's 1. So it's about right here. That's B. Okay. The angle theta is between those two. So it's actually going here. This is my angle theta. 172 degrees. Okay. So that's the dot product. Okay. We're going to talk about the last way that we can multiply vectors, but before we do, we need to talk a little bit about the geometry of vectors. A little bit more about geometry. So let's say we have these two vectors again. We've got vector A, and we've got vector B. I'm going to just draw it this way. Okay. And we've got some angle between these two, theta. Okay. Excuse me. Might have to do something a little bit on the, well, anyway. All right, so any two vectors, any two non-parallel vectors create a plane or define a plane. Okay, so I've got what's called an AB plane. So if I extend B, let me try to do some perpendicular here. So that's B again. And then I've got A. It's not going to be perfect. I apologize, but I'm doing the best I can. Okay, so that's A and B. Kind of not perfect again. This area here is the AB plane. Okay, it makes a plane like a sheet of paper. So one edge of the sheet of paper is A, the other edge of the sheet of paper is B, and we fill all that in. It makes a plane called AB. All right, and that's the entire paper. Excuse me. That's our AB plane. And so if we're trying to find the area, right, this is not a perfect square or circle, or I mean square or rectangle or anything. So to find the area, we're going to have to find this height for A times B, right? So this is going to be, given that angle, that's the opposite side. This is the hypotenuse here. So this would be my hypotenuse. Oops, my hypotenuse. This would be the opposite side to the angle. So I would have a sine theta. Okay, so it would be A times sine theta would give me this length here from here to here. And then I could multiply that times the magnitude of B. Okay, so the area of that square or that quadrilateral is going to equal to A sine theta times B. Okay, that's the equation that we use. That's just from geometry. And so you'll see that this is just equal to AB sine of theta. So AB sine theta is the area contained by the AB plane. Right? Where theta is just the is the angle between A and B. Okay. Also, perpendicular to both of these, we're going to have another vector that we're calling n hat right now. What's called n hat. Okay, so n hat. And n hat is going to be perpendicular to both A and B. Okay, it's perpendicular to both A and B. There's a bit of lag today, at least on my end. Are y'all getting a lot of lag?
No, sir.
Okay, good. It's just on my end. All right. Thank you. Shh. Let's see here. Okay, so n hat is the normal vector. That's why we give it an n, is the normal vector by normal, again, we just mean 90 degrees. Okay, that's why we call it a normal force. The normal force always acts 90 degrees to the surface, right? The normal force, and so here the normal vector is 90 degrees. That's why we call it normal. Normal vector to the AB plane. I always look over here because this is where y'all's faces are. I should be looking at the camera. I'm still not used to that. AB plane. And it's perpendicular to both A and B. That's what normal means. To both, to both vectors A and B. Okay. And so this is where the cross product comes from. And so we can define it now. So the cross product, so whenever I multiply these two to get the area there, so to speak, the cross product gives me that area and it gives me the direction of n hat. Okay. A cross B. It's going to give me, so it's going to be A times B. So those are the magnitudes A and B times sine of theta n hat. All right. Okay, so this again, this was the area of the plane. And this gives me the direction for that plane that's 90 degrees from that plane. Okay. So this is the cross product. All right, that's our cross product. It's so unlike the dot product, the cross product is another vector. We've got a question.
Oh, no, sir.
Oh, okay.
Sorry.
No problem. This is a unit vector. N hat is a unit vector. Okay, it's another vector. So what we've got here is another vector. So the result of a cross product is another vector. Okay. And the direction, the direction of the resulting vector is perpendicular to the two original vectors. Which in this case would be A and B vectors. Okay. So we already talked about that. Nothing there. All right, so I'm going to explain a little bit about the direction of the cross product. This is going to be difficult for me to do, so bear with me. The reason is because it's very difficult to show. There's some right-hand rule stuff that we need to learn here, and that's very difficult to show on here. So I'm going to do my best, but you might have to go and look at examples of a right-hand rule on YouTube or something for a better example. So look up right-hand rule on YouTube. Okay, so you guys have a better idea of the direction of the cross product and whatnot. Okay, so write this down as quickly as you can. Let's see. I think let's see. Let's see how it works out. Okay, so it says find the direction of the cross product if vector A lies along the positive x-axis and vector B lies along the negative y-axis. All right, so we're trying to find just the direction of the cross product. Okay, we don't need to know anything about the numbers. We just care about the direction, and that's very easily done with the right-hand rule if you know what it is. All right, so it says that the A vector lies along the positive x-axis, so it doesn't matter what the magnitude is for this particular problem. I just know that A is going in that direction. And then it says B lies along the negative y-axis, so it's going down. That's my B. What direction is N, or N hat? That's what we're looking for. So when it's asking find the direction, it's asking for what is N hat? What direction is N hat? Okay, and that's where the right-hand rule comes in. All right, so usually the way the right-hand rule goes, this is going to be my first vector. My index finger is my first vector. My middle finger is going to be my second vector. And the thumb is going to be the direction of the third vector. And so all I have to do is point my index finger and my middle finger in the same directions as I see there. So this would be A. This is my first vector A. This is my second vector B. And I just need to point these in the same direction that I see on my paper. So this needs to go in the positive X direction, which would be to my left, that would be your right, I hope, and point my middle finger down in the negative X, Y direction, like this. And so you'll see if you do that, if you point your finger down to your left, which is the positive X, and this one down, you'll see that it goes towards you. If you turn it into the direction of your paper, if you draw this on your paper, you point A. Is that showing up correctly? I can't tell. This is so difficult to do. Let me see if you can do this. Yeah. Okay, so hopefully you guys can see that. So that's A. I'm pointing my index finger in the direction of A, my B finger down in the negative Y direction, and you'll see that my thumb is going into the page. So that's the direction of my in hat. Okay, that's the direction of my in hat. And so how do we draw this on a graph? We use, it's like an arrowhead. So if it's going into the page, we're seeing the feather end of the arrow, right? So we've got an arrow. When it's coming out of the page, we draw it like this, like the point of the arrow's coming at us. When it's going into the page, we draw it like this. Okay, so in this case, again, I've got A going, this is so hard to do. A going to the, dang it. See if I can do it. A going to in that direction, that's my end of finger. B going down, and N going into the page there. Okay, so hopefully you guys can see that. So I would draw it as this little X. I'm watching the arrowhead go away from me, or the arrow go away from me. So I would draw it like this. That's my in hat. It's going into the page. I hope that makes sense. It's very difficult to do like this without like a whiteboard that I can work off of behind me. So let's try the second one. Vector A lies along the negative x-axis. So now A is going this way. And you guys try this and tell me what you get. Just type in the chat into the page or out of the page for in hat. And then B's going still in the negative y. So you guys just kind of play around a moment. Tell me which direction the in hat is going in this case. You can just type it in the chat, into the page or out of the page.
It would be going out.
Yeah, okay, so I got several answers saying it's going out. It would be going out of the page. So again, I've got my my index finger in the A direction. I've got B going down, and so my thumb's pointing out of the page. So it would be coming out of the page. So I would draw it like this. That would be my in hat. All right, so good. Out of the page. Yes, out of the page. Good job. All right. Look that up more on YouTube because I'm sure that there's better ways to visualize that. I know that there are better ways to do that, but I'm limited with what materials I have here. So, all right, good job. So that's good. That's a cross product. We've got an equation, but there's still a little bit more to it. First, we've got the cross product properties. Properties for the cross product. Just here, cross product properties. There's it's commutative. So A cross B. Now there's a little caveat to that. We can switch these around, but it's going to be the negative of it. So it's going to be a negative B cross A. All right. So with the dot product, it was A dot B is equal to B dot A. Fine. We can do the same with the cross product, but we have a negative. Okay, so it's A cross B is equal to the negative of B cross A. It is distributive. So A cross B cross C is going to equal to A cross B. That should be plus, sorry, that should be plus, not cross. Is equal to A cross B plus A cross C. Okay. And for differentiation, we have to use the product rule. That's what I was trying to remember what that rule was called last period, the product rule. For differentiation, when we differentiate, when we're taking the derivative of cross product, let's say, for example, of T, A cross B would equal to the derivative of A cross with B plus A cross with the derivative of B with respect to T. Right, so we would use the product rule. The word product wouldn't come to mind earlier. All right. Unit vectors. Right, so we did this with the dot product. If I do the I cross I, we're going to get I times I, right? The magnitude of I times sine of theta in hat. And so for the sake of time, I'm not going to ask a lot of questions here. Theta is going to equal to 0. The magnitude of I hat is 1, right? So we're going to end up here with a 0. Right? So any vector crossed with itself is 0. In fact, any parallel vectors when crossed, let's say when crossed, will result in 0. Okay. How about two different? So let's do I cross J. That's going to be I times J sine of theta in hat, right? Well, these are 90 degrees to each other, and the magnitudes of both is 1. So we're going to have a 1 times a sine of 90 degrees in hat. Excuse me. And so we'll get 1 in hat. So we'll just get in hat. Now, if I draw this, right, this is the I hat direction. This is I hat. This is J hat. And so we already know, we talked about that the 90 degrees from that, that's going to be K hat. So this is actually K hat. So that tells us that I cross J, as long as we go in the direction of the alphabet and then back around. So I cross J is going to equal to K hat. J crossed K is going to equal to I hat. And then K cross I is going to equal to J hat. And we can go the other way around too. So J hat crossed I hat is going to be equal to negative K hat. K hat crossed J hat is going to equal to negative I hat. And I hat crossed K hat is going to equal to a negative J hat. Right? The other thing that this tells us is if two vectors are perpendicular, then the cross product is always going to be 1. Okay. Then just as with the dot product, we had two equations that we could use to solve for the dot product. We had one in terms of cosine theta and the other one in terms of the magnitudes of the components of the two vectors. We have the same thing here, but we have to use a slightly different method. So what we need to do for the cross product here is we need to use what's called the determinant method. Right? But note that this only works for Cartesian coordinates, right? Not in any other coordinate system. We usually think coordinate system as just Cartesian. That's what we treat. But there's a bunch of different ones. There's like I think it's called like taxi cab coordinate system. There's one called there's something called K-space, which is a little different. We can use an NT, a normal and tangential coordinate system. We've got a spherical coordinate system, and others, but this method only works for the Cartesian coordinate system, X, Y, and Z. So A is equal to AX I hat plus AY J hat and plus AZ K hat, right? So that's one. And then B we've seen is BX I hat plus BY J hat plus BZ K hat, right? So what is the determinant method? All right. We've got A cross B is equal to, so we draw this line. It's kind of a matrix. So we draw this line. And in the first row, we're going to put the I hat, J hat, and K hat. This is always the same. I hat, J hat, K hat. On the second row, we're going to put the magnitudes of our first vector. So that would be, in this case, AX, AY, and AZ. And then in the third row, we're going to put the magnitudes for our second vector, which are going to be BX, BY, and BZ. All right, so give me a second to switch this because I'm going to have to kind of switch between my computer and the note here to do this properly. There we go. Okay. Oh, there's too much 5. That's not going to work. So tired of this. All right. Well, I'll do my best to do this as it is. All right. So the first thing we want to do is the I hat components. Okay. So for I hat, so the first thing we do is we do I hat. So I'm going to write down I hat here, and I'm going to do open bracket. For the I hat component, all right, so I'm on here, I'm on I hat. I am going to ignore everything here and everything here. Okay, so I'm only looking at these 4 variables here, AY, AZ, BY, and BZ. And so I'm going to multiply these. So I'm going to do A times AY times BZ. So I'm going this way. It would be AY times BZ. And then I'm going to loop back up and I'm going to do AZ times BY. And it's going to be, so it's going to be a minus AZ times BY. And close that, right? So I hat, and this is a positive I hat, and you'll see why I'm writing that here in a bit. This positive I hat is equal to that. For the J hat, so now I'm doing J hat, so it's going to be a minus J hat. So I'm going here, and I'm ignoring everything in that row and column. Okay, so I'm only going to consider this, 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 and this now. And we do the same looped. So we start on the upper left, AX times BZ. And we loop up, and then AZ times BX. So it's going to be minus AZ times BX. And there's another way to do this that I'll show you here in a bit that some people prefer over this. So that's K hat. So now I'm doing the K hat. Just let me pick a different color here that's going to stand out. Blue. All right. And so now I'm circling the K hat. I'm going to ignore everything in that row and column. This is getting messy. So I only consider these four now. So it's going to be AX times BY minus, I'm going to loop back up. It's going to be AY times BX. Okay. And so that's our equation. That's what we write. So A cross B is equal to AYBZ minus AZBY I hat minus AXBZ minus AZBX J hat plus AXBY minus AYBX K hat. Right? That's my preferred way of doing the determinant. But there is another way that some people like better, some students and some other instructors prefer. I like this method because it already leaves everything together. So all my I hat components are together, my J hat components are good, my K hat components are already together. This other method is a little bit easier to visualize, I guess, or do, but I feel it leaves kind of a mess. So you guys determine which method you prefer and go with it. I don't care which one you use as long as you understand how to get to the result. All right, so the second way to do this equal to same setup here at the beginning. IJK this is AX AY AZ. This is BX BY BZ. And then I'm going to write an extra 2 columns on the right outside of the determinant. So I'm going to write I and J, AX, AY, BX, BY. Right? And then what we do is we multiply where there's 3 in a row diagonally. So it would go this way, and this way, and then it would go this way, and this way. So it would be AYBX minus. So everything going from right to left is going to be minus. So there's going to be minus AYBX minus AZBY sure that's right. Minus AZB, minus AZBY, minus AXBZ. And then the arrows going down from left to right are going to be positive. So it'd be a plus AYBZ. And I forgot the K hat. So this one would be K hat. This one would be I hat. This one would be J hat. This one would be AYBZ I hat plus AZBX J hat. Yeah. Plus AXBY. Yeah. BX AXBY K hat. All right. So that's A cross B. And so now I'd have an extra step of putting everything together. So A cross B would equal 2. So I'd start with my I. So AYBZ minus AZBY I hat. So that takes care of this one and this one. And then we would add everything here. So it's going to be J hat AZBX minus AXBZ J hat plus, so that takes care of the J hat here, the J hat here, and then we have AXBY plus minus AYBX. Okay, so the only difference might be these in this one up here and this one is these are switched around and we have a negative. It's just because it's multiplied by a negative. That's it. So if I take out this negative, it's going to be a minus AXBZ minus AZBX and those switch. That's it. Otherwise, everything else is the same. For me, this can get very confusing if you're not being careful. This is a lot easier. I can do this right away in my head. I can just go, this times this is this, minus this times this is this, and boom, you're done. And this tends, in my mind, is a little bit more confusing, but you guys do whatever you're more comfortable with. As long as you practice and stay consistent. Pick one of these methods and be consistent throughout so that you learn it well, okay? Are there any questions?
On the homework, there there's one question that says you have to put the answer in vector unit notation, but
Yeah.
on the other question, there's some questions where you have to like add and subtract, and it doesn't say that. Do you think it's okay if we just put it in normal, like just as a number? I guess is that what you were looking for?
Be more,
Like for number 3.
Let me open up my.
Yeah, like for number 3, it says.
You know what? I'll take questions a little bit. Let's finish this and then I'll look at that because we've got one more thing I want to cover before we go for spring break. And then if you want to stick around, I can answer that for you.
It's fine.
Okay. All right. Because if I answer that now, we won't have time to finish the notes. All right. So here's an example. Okay. Of the cross product. We're given that A is 2I plus 3J plus 4K and B is 4I minus 2J plus K. Find the cross product A cross B. And so I'm going to do exactly what I did earlier. All right, so I put down IJK in the first row. In the second row, I'm going to put my components for A. So that's going to be a 2, a 3, and a 4. And then in the third row, I'm going to put a 4, a -2. Don't forget that negative, -2. And there's a 1 with that K, so I'm going to put a 1. Otherwise, the K wouldn't be there. It would be 0. Okay, so I'm doing the I hat component first. It's going to be 3 times 1. That's 3. Minus a 4 times a negative 2 gives me a negative 8. I hat. Minus, now I'm doing the j component. So I'm going to 2 times 1 is 2. Minus a 4 times 4 is 16. J hat. And then plus a 2 times negative 2 gives me a negative 4, minus a 3 times 4 gives me 12. And now I just solved that. So A cross B is going to equal to a 3 minus a negative 8. That becomes a 3 plus 8. That's going to be 11. I hat. Then that's going to be a minus. That's 2 minus 16 being a negative 14. So it's a minus times a minus gives me a plus positive 14 j hat. Okay, so make sure you don't get confused with all these negatives and stuff, all right? Keep those in line. That's why make sure you're including parentheses here so you don't get that confused. Parentheses are important. Then plus a negative 4 minus a 12 gives me a negative 16. So a plus times a minus gives me a negative 16 k hat. Okay, so I had a little bit more time than I thought. That took a lot less time than I thought it would. Any questions? There might be some questions on that one. Any questions on that?
No, sir.
Okay. All right. So you said like a number 3. So let me open up where is it? Vectors. There we go. All right. So for like number 3, given, what is the vector? Yeah, you're just doing scalar multiplication and addition. So we covered that on the other days. We covered that on Monday and Tuesday.
Okay.
So you're still going to have I hats and J hats. That the only time we get rid of our I hats and J hats is when we do the dot product. It's only the dot product that we end up with a scalar value. Or if we're finding the magnitude, but that's not even the scalar, that's the magnitude.
So here, we do use the unit vector still.
Yes, the unit vectors do not go away. It only goes away with the dot product. Yeah. If we're finding components, there's no vector. Obviously, that's going to be the magnitudes of the X and Y components. But yeah, whenever we're in vector notation, the I hats and J hats only go away when we do the dot product. Yeah. Any other questions?
I have a question, sir.
For question
About-
5. Go for it.
Yeah, about the questions 4. What is the angle between A and B? How can I find the angle?
I just did a problem like that. We did a problem like that at the beginning of the class. Exactly like that. Today. I did a problem exactly like that at the beginning of the class here for this one. Right here. So if you're late, you didn't get it. That's why you guys need to try to be on time. I know that can be hard sometimes. So you can go back and watch the video for that one. It's at the very beginning of the video. And then I got a question for number 5. What's the question for number 5? So does I and J both equal to 0? Yes, I and J would both be 0 for number 5. There's the notes for that problem we did that covers that. This is basically what you need right here. So you already found A dot B. In the first part of that problem, you'd already found A dot B. You need the magnitudes of A and B, which I did here. And then you just do the inverse cosine of A dot B on top. times the magnitude, or divided by the multiplication of the magnitudes on the bottom there. Go down a little bit. Cool. Does that work? I explained it better in the video. I don't want to go through all of that again right now, but I'll have the video up here in a bit. In fact, let me take care of this real quick before I end the thing, because then it'll give me issues. Go here. Okay. Here we go. Okay. There we go. All right. So I'll have the video up. It should be up within 30 minutes after I close things down here. Are there any other questions?
I do have for. It was just more about negative vectors. Like if we try to find the magnitude, it's usually just the same as if both numbers are positive, right?
Are you talking like for number 2?
Yeah, for number 1 and 2, because I don't know, just it's because it's facing the other way. So I assume that even though one aspect, or one part of the vector, the vertical or horizontal, is negative, they both get squared anyway, so the magnitude would still be the same.
Yeah, the magnitude, when you get the magnitude, you're going to get just it's just the number. The direction comes from the theta. That's where we get whether it's in the first, second, third, or fourth quadrants and whatnot from the theta.
Okay.
Yeah.
And
Now, if
think,
I'm sorry. Say that again. I can't. You're coming in and out.
Yeah, I'm sorry. I was just going to say that I think I had another question, but I forgot it.
Okay.
And
so just to cover for number 2, finally, so we can finish this. For number 2, when it's asking you to find the AX and AY, the X and Y components, you will get a negative or a positive. You can get a negative or positive for that. Whenever you're looking for the components of a vector, you can get negative or positive for that one.
like, for example, since the X is facing the other way, that one would probably be the negative one, right?
For number 1?
Oh, my bad. For number 2,
Yeah.
you get
For number 2, yeah, you just use let's see, it's going to be a cosine theta, and then for the X component, and a sine theta for the Y component, and you could get a negative or positive for one of those or both.
Okay. All right.
Okay. Yeah, y'all can always email me if you're still lost or something. I'll help. Yeah, I don't know what else to say. All right, I'll see y'all on. Enjoy your spring break. I'll see you on that Monday after. Ready to go. We're going to cover 2D motion. We're going to go into 2D motion now that we saw vectors, 2-dimensional motion. Then we're going to do an exam. And I think then after that, it's circular motion, if I remember correctly. So we'll see you guys after spring break. Have some fun, right? Be responsible, have some fun. Don't go too crazy. Be careful, be safe, stay healthy.
Thank you, sir. Have a good day.
Bye.
Good.